Alright people, this is a huge day. We're going to come up with a result that is just going to blow your mind. If you've never seen the quadratic formula before, we're going to figure it out, we're going to see it, and we're going to understand where it comes from. Now I made this claim during the last video that you can complete the square on anything, and that's going to be really true here. We're going to solve for x, that is isolate x, get x all by itself, by completing the square. Not only are we going to have fractions, and don't fear the fraction, we're going to have variables here. You might say, Bergman, how are we going to complete the square on something where there's no numbers? Well, we're just going to do the same techniques that we did last time, pretending that we had numbers. So it looks like this. We want to get rid of the a value because it's way easier to complete the square with an x squared term than it is with an ax squared. So divide both sides, all the terms on both sides by a, and immediately we're going to have fractions. I'm just letting you know right now, everything is going to have fractions from here at this point out. That's okay, we can handle it. B over a, x, plus c over a is still going to equal 0. The next step is to subtract c over a from both sides, and we get x squared plus b over a, x, with a little space, equals negative c over a. What are we going to fill that little space with? B over a divided by 2, and that's the same thing as multiply by 1/2. B over 2a, and then when you square it, you get b squared over 4a squared. So this b squared over 4a squared is what we're going to add to both sides. And then the b over 2a is going to be what we have inside the parentheses. Now, of course, I want to make sure I can combine the two fractions, so I need to get a common denominator, which is 4a squared. So therefore, I can multiply both the numerator and the denominator by 4a, so that I get a common denominator of 4a squared. This 4a times negative c would be negative 4ac, and then I can add these two fractions together. You get negative 4ac on the top and b squared also, which I can't combine any further, but they're in the same fraction at least. And that's all equal to the quantity x plus b over 2a squared. Just recopying. Then I take the square root of both sides. You get x plus b over 2a is equal to, rearranging the terms, I'm going to put b squared first, minus 4ac, all over 4a squared. I'm going to take this, of course I have to take the square root of both sides. Simplifying the right-hand side, oh, and I also need the plus or minus. Simplifying the right-hand side, you get plus or minus the square root of the numerator, b squared minus 4ac, all over the square root of the denominator, which is 2a. I'm going to subtract b over 2a from both sides. You get x is equal to b, negative b, all over 2a, plus or minus the square root of b squared minus 4ac, also over 2a. And then combining the fractions, we get x is equal to negative b plus or minus the square root of b squared minus 4ac, all over 2a.
equals negative b plus or minus square root b squared minus 4ac divided by 2a. 2a! 2a! 2a!
Quadratic formula is a breeze. Identify A, B, and C. Then you gotta plug them into the formula. Begin by setting it up. Here's how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you know the way to positive x with an a.
Negative b plus or minus the square root of b squared minus 4ac over 2a.
X equals negative b
Plus or minus the square root of b squared minus 4ac all over 2a.
Ever since I learned this way to solve, I've got a reputation for my math now.
So there it is, the quadratic formula. It's huge, it's famous. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a great way to memorize it if you're melodic or if you're musically inclined or memorize things by songs. If you memorize things by stories, you can think of this story. A negative boy was unsure about a radical party. The boy was a square, and he missed out on 4 awesome chicks. It was all over by 2 a.m. Well, and when we say chicks, what we really mean is like baby chickens that have just hatched. Who am I kidding? This is not exactly the most gender equitable way to memorize, but if this works for you, then you can use it. Okay, so what this all means, and this is why everyone goes crazy over it, is because as long as you identify what the A value is, and the B value, and the C value, you can basically write what the answer is in one step. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is, there's your answer, and all you have to do really is simplify it. That's the hardest part, simplifying that huge long fraction with a square root inside. So let's do it. Negative 3 plus or minus the square root of 9 plus 16 all over 2 times 4, which is 8. X is equal to negative 3 plus or minus the square root of 25, which is 5, all over 8. X is going to equal negative 3 plus 5, which is 2 over 8, or negative 3 minus 5, which is negative 8. When you simplify it down, you get x equals 1/4, or x equals negative 1. This is actually an example that we had from the notes from yesterday. You may or may not remember it, but if you flip over, you can see that we did this by completing the square. And so I ask you, it's kind of a question, which is easier, using the quadratic formula or completing the square? Simplifying the quadratic formula is all the work, but eventually you get the right answer. The same answer as you got when you completed the square. Let's do that again over here. Now notice that it's not all equal to 0, and the quadratic formula assumes that you started out with, everything equal to 0. So that's kind of got to be a first step here. We have to make sure that we move all the terms over to one side by subtracting 3 in this case. 5x squared minus 8x minus 3 is equal to 0. The a value is 5. The b value is negative 8. The c value is negative 3. So therefore, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Great. So now you can see the b value is negative, so it's really good to make sure you have it inside parentheses, and therefore you can avoid your sign mistakes that often happen. Okay, because I put the b value in parentheses, I can see that this is going to be positive 8 plus or minus the square root of 64. These two, the minus and the negative cancel, so we get plus 4 times 5, which is 20, plus 3, which is times 3, which is 60. 64 plus 60 over 10. I'm going to do some side work and say that the square root of 64 plus 60 is 124. You can split that up. You can simplify that into the square root of 4 times the square root of 31, and that's just 2 root 31. So therefore, as an answer, you simplify your answer to get 8 plus or minus 2 root 31 over 10. I'm going to factor out a 2. So you get x is equal to 2 times 4 plus or minus the square root of 31 all over 2 times 5. So the 2's cancel. And you get x is equal to 4 plus or minus the square root of 31 over 5. Here, let's figure out what the a values are. A is equal to 1, b is equal to negative 1, and then c is equal to positive 2. X equals negative p plus or minus the square root of b squared minus 4ac all over 2a. X, let's simplify that. We get 1 plus or minus the square root of 1 minus 8 over 2. Uh-oh. I'm smelling some imaginary numbers here. X is going to equal 1 plus or minus the square root of negative 7 all over 2. We can't take the square root of negative 7. Oh, yes, we can. In fact, the whole reason why we spent the past 3 days developing quadratic formulas and equations and complex numbers before that was the fact that we are able to simplify this down, and we can always get 2 answers. Sometimes they'll be real, sometimes they'll be imaginary or complex. But we can continue, we can move forward, because we can factor out the I square roots of 7 over 2. And that, my friends, is the answer. It might be a crazy complex answer. When I say complex, I literally mean real plus imaginary is complex. It might have a square root, but there are 2 solutions here, and there they are. 1 plus I root 7 over 2, and 1 minus I root 7 over 2. Here's your audio check, good people. The quadratic formula covering all the cases was first obtained by Simon Stevin in 1594. Again, Simon Stevin in 1594 was the first person to obtain the quadratic formula. Now let's talk about the discriminant. The discriminant is just b squared minus 4ac, and otherwise known as that big hairy mess inside the square root here, b squared minus 4ac. If everything inside that square root, that big hairy mess, turns into 0, then it looks like this. Negative b plus or minus the square root of 0, which is just the same thing as negative b over 2a. In fact, what that means is, if big hairy mess is equal to 0, then you'll get 1 real solution. You can just predict that you'll have 1 answer. It won't be plus or minus anything because you've been plus or minusing 0. If b squared minus 4ac, the discriminant, that big hairy mess inside the square root, is greater than 0, then you're going to get something that's positive. Negative b plus or minus the square root of something positive over 2a. and then you'll get two different real solutions. They won't be the same, they'll be two different ones, and then at least they won't have an I value in it. It'll be positive, like most normal numbers. And if b squared minus 4ac is negative, if it's less than 0, then that big hairy mess inside the square roots is going to be negative. And then you will get a complex solution. You get two of them, two complex solutions, and not only that, they're going to be conjugates of each other, complex conjugates. Let me show you what I mean. So, the instructions here say determine the nature of the solutions by evaluating the discriminant. So A is going to equal 1, B is going to equal 5, and C is going to equal negative 3. The discriminant is b squared minus 4ac, b squared minus 4ac. It's the part that's inside the square root. If that is going, let's see what it is. It's b squared is 5 squared minus 4 times 1 times c, which is negative 3. So that's going to be positive. In fact, 25 times, see this, these cancel. 25 plus 12 is 37. 37 is definitely greater than 0. So that means that the stuff inside the square root is going to be positive. So we're going to have 2 real solutions. That's what we mean by the nature of the answer, of the solutions. You're going to get two answers and they'll both be real. They won't have any I values and they'll be different from each other. A is equal to 9. B is equal to negative 6. C is equal to 1. The discriminant is b squared minus 4ac. Remember the big hairy mess inside the square root. And when we fill in the variables, we get negative 6 squared minus 4 times 9 times 1. Simplifying a little bit, we get 36 minus 36, which is 0. And remember from our little cheat sheet here, if b squared minus 4ac is equal to 0, then they'll get one real solution. It'll be negative b over 2a because everything else simplifies. So the answer to this question is one real solution. One real solution. I want you to do number 25. And it's going to be one of these three cases. Either it's going to be one real solution, two different real solutions, or two complex conjugate solutions. That's the format of the answer that we're looking for. Next, writing equations from solutions. Find a quadratic equation having the following solutions. So notice here we're given two values, two solutions. We could say that x could equal negative 4 and x could equal 5 over 3. And so the question is, if we know that, maybe we can work backwards and come up with the equation that produced these solutions in the first place. So what I'm trying to say is, if we have the solutions, we should be able to work backwards to get the equations. X equals negative 4 and x equals 5 over 3. This is going to be a straightforward process, and I've even written out the steps over here. First step would be to write as x could equal negative 4 or x could equal 5 over 3. We're going to solve for 0. I mean, normally what we would do is we would take this, we're going to add 4 to both sides. So you get x plus 4 is equal to 0. Or x minus 5 over 3 could equal 0. Normally we start out with this and we subtract 4 to this and we say that we get two answers. Normally we have this when going in this direction, but we're working our way backwards to come up with one unified equation. I'm going to clear this fraction. I'm going to multiply all the terms on both sides by 3 just because I can. And we get 3x minus 5 is equal to 0 times 3, which is 0. Great. Now we're going to combine the two equations together. X plus 4 times 3x minus 5 equals 0. Now remember, we normally see this in the opposite order. Normally we're given this and we split it up and solve to get two solutions. But now we're working backwards and instead of splitting up equations, we're combining them. And when we FOIL, we get 3x squared plus 12x minus 5x minus 20 is equal to 0. Combining the like terms, we get 3x squared plus 7x minus 20. How crazy is that? These two solutions dictated this equation. Now, notice that the instructions say find a quadratic equation. There's actually a wide variety of equations that will have this solution. For example, I don't want to confuse you. This is the answer, and you can stop there. But if you wanted to, you can multiply all the terms on both sides by, say, 10, if you wanted to, and you get 30x squared plus 70x minus 200 is equal to 0. And you would still be able to get that equation, and therefore all these solutions too. So it's not like there's just one solution, one answer, but there's one simplest one at least. And here it is. Your answer is 3x squared plus 7x minus 20 equals 0. Let's do that here. Let's do all the steps. Same steps with two different numbers. Write as x equals negative 2 root 2, or x equals square root of 2. Then solve for 0. We get x, adding 2 square roots of 2 to both sides, we get x2, 2 square roots of 2 equals 0, or x minus square root of 2 is equal to 0. And then you can combine those two separate equations into one equation, because they're both equal to 0. X plus 2 square roots of 2 times x minus square root of 2 is equal to 0. When you FOIL all that out, you get x squared, and then outside term is negative, or minus square root of 2x, and then inside term would be plus 2 square roots of 2x, and then last term would be 2 times square root of 2 times square root of 2, all equals 0. Simplify things a little bit, you get x squared. These are like terms, so you get x squared plus square root of 2x minus 4 is equal to 0. That is an equation that will solve to get these two solutions. 5i and negative 5i. Alright, here we go. X could equal 5i, or x could equal negative 5i. Writing out the next part, you add 5i to both sides, or subtract 5i, and you get x minus 5i equals 0, or x plus 5i equals 0. And then you can combine the two into one equation, which looks like this. These are complex conjugates, so when we FOIL them, the middle two terms are going to cancel out. We're just going to be left with x squared minus 5i squared. 5i squared, which is equal to 0. And if we simplify that, we know that this is going to be x squared minus 5 squared is 25, and I squared is negative 1, equals 0. Simplifying it one last step, we get x squared plus 25 is equal to 0. This is one equation that will have those two solutions if you try and solve it. So I'd like you to begin assignment 2E2. That means copy the problem list and do the first problem, and I will see you in class. Take care.